Hi, my name is Tenzin. This is my assignment 2 for Comp3132. Okay, so I've mounted my Google Drive and stored the Iris CSV file in the variable name file name. I've imported the pandas. The dataset basically contains measurements of flowers. Each row represents one flower sample. Here I've used the .head function to display the first 5 rows. The species column here contains categorical values which I've converted to integers. And then I've displayed the rows again. Here the first 4 columns represents input features, and I've stored them in the variable x. The last column represents the target variable, and it's stored in the variable y. Here I've split the dataset into training and testing sets, 80% for training and 20% for testing. And here I've displayed the first few rows of the training and testing sets. This basically confirms the data was split correctly. And as you can see, 120 for training and 30 for testing, which is basically 80-20 split. For neural network output probabilities, basically for multi-class classification, we use one-hot encoding. And here, as you can see, 1 becomes 0. This one right here, this bracket here, 0, 1, 0, and 0 is basically 1, 0, 0, etc. Excuse me. So this matches the softmax output layer. Here I've created a sequential neural network. The first hidden layer has 100 neurons with ReLU activation, and the second one also has 100. The output layer has 3 neurons with softmax. Softmax basically converts output into probabilities. I use RMS prop optimizer, and I use categorical cross entropy because this is a multi-class classification. So I use accuracy as a evaluation metric here. And then, so I trained the model for 20 epochs, and then the batch size is 10. An epoch basically represents one full pass through the dataset. The model learns by adjusting weights during the training. And here I evaluated the model on the test sets. This shows how well the model generalizes, and the accuracy is approximately 89%. A high accuracy indicates a good performance. Here I created a second model with fewer hidden units. Instead of 100, I used 10, and also for the second layer. And then I use 10 neurons per layer, yeah, and which this basically reduces the model complexity. And here I use the same optimizer and the loss function, and basically this allows a fair comparison between the models. And I trained the smaller model for only 4 epochs, leaving the same batch size. It allows for comparison between the training duration and the performance. And as you can see, the accuracy has decreased a bit. It may be due to fewer neurons and fewer epochs, basically. Okay. So for 10A, basically, increasing hidden units increases model capacity, right? And more neurons can learn more complex pattern. but however, too many neurons may cause overfitting, and too few neurons may cause underfitting, to answer the question here. And there must be a good balance between complexity and generalization. That's what we have learned from this. And so for 10b, in this section, I basically experimented by changing one parameter at a time. I changed first the optimizer to see how it affects convergence speed. And then I adjusted here the number of hidden units to analyze the model complexity. And then I also increased the number of epochs to observe how longer training impacts accuracy. So these experiments basically help demonstrate how hyperparameters influence model performance. And overall, the performance basically varies depending on the balance between model capacity and training settings.